Hey all, Chapter 8 is going to be talking about sequences and series. So our basic two types are arithmetic and geometric. So a sequence is just a pattern usually dealing with numbers, and it has a common difference, meaning you're adding or subtracting by the same thing each time, or multiplying or dividing by the same thing each time. So arithmetic is going to be a plus or minus. Geometric is going to be multiplication or division. And if we look at these two that we're working with, we've got 3, 7, 11, and 15. First term is 3, 7, 11, 15. Those are given. And then our pattern each time is adding 4. All the way down through here. So our next one would be 19, and then after that is 23. And we want to be able to generalize because problems on your homework or down the road are going to ask, what's the 100th term? And we don't want to keep going through this one by one. We'd rather just have a shortcut. And so that's the idea here. So our n is referring to the term number. And when n was 1, we got the number 3. And when n was 2, we got the number 7. And when n is 3, we got the number 11. Okay, so instinctively, I'm hoping that you're seeing this 4 has to be somewhere in this equation. But when we think about arithmetic, the easy way to compare it is by using what we know has a constant increase from algebra, and that's a line. So y equals mx plus b. And our constant difference is talking about our slope. So if we're thinking about the n term, we might call this 4n. Okay, so if I take 4 times 1, I get 4, I don't get 3, so there's a problem. Same thing, 4 times 2 is 8, not 7. 4 times 3 is 12, not 11, but hopefully you notice, if I subtract 1, I fix the problem. Okay, well this comes from the second piece being the y-intercept, and the y-intercept is when the x value is 0. So for us, that would mean the term right before that. So the term right before 3, if you reverse the pattern, would be -1. All right, then if we look over here, we're given our first 4 again, 3, 6, 12, 24, but the pattern this time is times 2 each time. And these ones are pretty obvious, but in general, when you're checking for an arithmetic pattern, you take second minus third, or sorry, second minus first, the number 3, to get your number. And as long as you do that for 2 pairs and they match, then it's arithmetic. For geometric, you're still going to go second, then first, third, then second, backwards, but if you're testing for multiplication division, we're going to take 6 over 3 and compare it to 12 over 6 to see if they match. Okay, so if it's not obvious, that's the route you're going to do. From here, we can see times 2, so 48, and then 96. And our nth term, we want to come up with a pattern just like we did for the last one. Okay, so this one's not necessarily as obvious to know what the algebraic relationship is because we're not as familiar with this type of equation as we are with lines. Okay, but if you're multiplying by the same thing each time, it's actually exponential, and our formula for that we normally use is ab to the x, where a is the first value or initial value, kind of like your y-intercept is over here, and then b is your base or your rate. Well, we know the rate is 2, and we're going to call it n because that's what they use here. And then our first term in our sequence was the number 3. But again, just like over here when we started with this equation, we had a little bit of an issue. Let's see what happens here. When n is 1, that says 3 times 2, which is 6. This one would say 3 times 2 to the second, which is 12. And it looks like we're just off a number. So our exponent's actually going to be subtracted by 1 to make this work for us. So first term, the rate, and then n minus 1. That takes care of the shift, just like we had to shift that first one. So your note card that you got for Chapter 8 has these formulas on there. This is the shift n minus 1, and when you actually distribute this d through, I fixed your note card so it's in front. That way we don't mess up and forget to distribute and simplify our formula. And then same thing, that n minus 1 shows up in the power. What we haven't talked about yet are what are called the recursive formulas, and the recursive formulas just say the nth term based on the term before it. So this n minus 1 just means the previous term, and it says add the same number to the previous term, because that's what makes something arithmetic. This one says take the previous term and multiply by the rate, because that's what makes something geometric. We will indicate that when we're talking about n in these formulas, we are talking about integers. For recursive, we're saying n greater than 1, because if you actually plug in 1, this doesn't work because we have a 0 term, which doesn't make very much sense. Okay, so we will say greater than 1 on that. Let's go ahead and work through some problems. The first 8, I think, or so, we're asked to identify the formulas as just recursive or explicit. Recursive are going to have fancy brackets, explicit won't. Easy as that. So we're just going to go through and answer all those things first, and then we'll come back for part B. So on your paper, everything with a bracket, I want you to go ahead and mark with an R for recursive. So first one works, second one doesn't. We're getting an E there for explicit. Third one does have a bracket. Fourth one does not, so it's explicit. Fifth one does, recursive. And last one is explicit. If you don't see that fancy bracket, we're going to call it explicit, no matter what the equation looks like. Okay, but part B is telling us to just list out the first 4 terms. And that is going to be a different process based on which type of equation we were given, recursive or explicit. If it's recursive, the first number is always assigned. So the first thing it tells you R1, first term, is 4. And then the second part tells us what to do with that number. Okay, so these are smushed, meaning it's multiplication, and we're going to multiply by a -3. Now we can multiply by -3 pretty quickly to get all 4 terms, but I do want to take this time to show you your calculator can help you with this. So in general, when you're dealing with a recursive equation, what you're going to do is type in the first number they give you and hit enter. And now that enter is pretty important. Then we're going to write what we're supposed to do to it. So in this case, the only thing it asks us is times -3. And that, if you keep hitting enter, will just repeat over and over and over again, completing your sequence. So we want 12, -36, +108. And again, for this, it's not necessarily quicker than doing it by hand, but it will help us for some more complicated equations like what we see in number 3. Okay, then on part C, we're supposed to find the 10th term. So we could continue this process. So I'm at the 4th. I could do 5th, 6th, 7th, 8th, 9th, 10th. And as long as you're careful, that's going to work out so that you can write your number just on that line, 78,732. No worries. Okay, but if this question asked for the 100th term instead, you wouldn't want to keep hitting enter that many times. So let's just get into practice of when you're given the explicit, or when you're not given the explicit equation, when you're given the recursive, we're going to go ahead and write the explicit using your note card. So because this was times, I'm going to skip to part D and it's going to help us with this. Because it was times, this is geometric, and you can abbreviate that. And because it's geometric, we're going to go to our note card and write down the formula you see that's explicit with geometric. It says the nth term is equal to the first term times the rate to the n minus 1 power. So our first term was -4, our rate was -3, and we just want to raise it to the n minus 1 power. We want the 10th term, so 10 minus 1 would be 9. And that will be equivalent to that 78,732. If I asked you for the 100th term, you could put a 99 here, and it saves you a bunch of time. Okay. On part 2, we're given explicit formula, so I'm going to show you again the shortcut for this. Because by hand, to get the first term, second term, third term, fourth term, we just plug in 1, plug in 2, plug in 3, and so on. So plugging in 1, that's negative 1 plus 7 is 6. Negative 2 plus 7 is 5. Negative 3 plus 7 is 4. And hopefully you're seeing the pattern here that we're just decreasing by 1 each time. I want you to start recognizing functions as what we know in algebra. This is a line, which means it's arithmetic. And if it's arithmetic, the slope is going to tell us what to count by. So you can plug in the first one and then just decrease by that. Alternatively, there's another way with your calculator, and this is going to be very important for you to do with me so we can do the more complicated equations. So if you're given explicit, I want you to go to your y equals and just type in the explicit equation that you see. So negative, we'll just call it x plus 7. From there, we're going to go to our table, and all of these values are going to show up corresponding with 1, 2, 3, and 4. We won't have to work hard. Okay, so your table's up with your graph. Hit second and then graph. And mine's all messed up funny, but yours shouldn't be. If it is for some reason, hit second table set. We want to start at like 1. We want to count by 1. And then go back. Oops, didn't hit second hard enough, I guess. There we go. And there's your numbers 6, 5, 4, 3. Copy them really quickly. Another benefit of this is now when we want to find the 10th term, we just scroll on down. There it is, negative 3. But again, plugging it in, n is 10, gets us there very quickly. All right, next one. Again, this is where we want to use our shortcut because our formula is just a little bit weird looking here. If you notice on that second part, it has multiplication and subtraction, which should tell you automatically this is a neither, because arithmetic is only addition, subtraction, geometric is only multiplication, division. But first step, remember, is type in the number that you're given for the first term. Hit enter. Then we're going to say what things are happening here. So we want to multiply by 2 and subtract 0.25. You have to do it in one step or the shortcut won't work. Okay, but there's the next term, then the next term, and the next term. So we'll go ahead and copy these down, 0.5, and then 0.75, 1.25, and 2.25. And you'll notice we're not increasing by a constant number each time. We're also not repeating a constant rate. So with this, we want to find the 10th term. Because this is not arithmetic or geometric, we don't have a formula. And if you can come up with a formula for the pattern of the numbers, go for it. It's not always easy to do that. So what we're going to do for this one, because it's only asking for the 10th term, is just continue our pattern. So this was our 4th. There's 5th, 6th, 7th, 8th, 9th, and 10th. So 128.25 is our answer for that. If it's not arithmetic or geometric strictly, I won't ever ask you for like the 50th term because I wouldn't want you to have to go through pressing that button that many times. Alright, so what I want you to do now that you've had a little bit of practice is pause the video and try 4, 5, and 6 for me, please. Alright, folks, so the first one, because it's explicit, we want to just type it into our y equals, remember, and then go to your table to fill out your values there. Looks like I typed in something wrong. Okay, and our list here now is -4, -13, -40, -121, like you see here. Just had to scroll up a little bit. And then, again, you can use the equation to plug in 10, but if it's already in your table, go ahead and just go down to the 10th one. If ever you're asked for the 100th, I would just change your table settings to start at 100, go back to your table, and there it is. And that it's a little bit faster than going and plugging in that 100 by hand. Okay, your choice though. And then finally, it is neither because this is a cubic. It has to be a line or an exponential to be arithmetic or geometric. Here we're squaring everything, so our numbers don't have a constant pattern in terms of multiplication or addition. So again, it is a neither. The pattern for this to find out the 10th is not as easy. If you were to take your, let me show you what happened. Take your 3, enter, and square it. Doing it second time, third time, fourth, fifth, sixth, seventh, eighth, ninth, it becomes too big to actually finish here. So we can actually follow this pattern. If you notice, this is 3 to the first, 3 squared, 3 to the fourth, and then past that you may not have recognized, but it's 3 to the 8th. So our powers are actually geometric because each time our powers are multiplying by 2. And if that's happening, then we can use that 2 to the n minus 1 power to talk about what 3 gets raised to. So for us, when we are looking at the 10th term, n minus 1 becomes 9, and then 2 to the 9th in your calculator is that 512, so it's 3 to the 512th power. Just something weird that happened where it was too big, too fast. That's not going to happen with arithmetic. It's not going to happen with geometric. Number 6 is a good example of an explicit that I wouldn't let you leave. If I ever ask you to write an equation, we always want this simplified. So this is something where you would fill it in with your note card first doing this, but then you'd need to distribute and simplify and call this -3n plus 15, so it looks like a line for me. Okay, when you can distribute, please do. But then our slope is -3, and our 0 term doesn't really exist, but that's 15, and then 12, 9, decreasing by 3 each time. Again, you can plug that in your y equals and check out your table to answer that and the 10th term. On number 7 and 8, we're supposed to write an explicit equation. We already did this for number 1. I showed you that we can write this as the nth term is -4 times the rate, -3 to the n minus 1 power. But what we haven't done is talked about how to write a recursive equation if we're given the explicit. Okay, so again, remember this is your slope, and this is your y-intercept, which is really your 0 term. Doesn't super exist, but we'll talk about how it's going to help us. So, first term on arithmetic, look at your note card here. It says just write A1 equals, and then right below it write AN equals. So first term and nth term. Then it says take AN minus 1, which is the previous term, and add the common difference. Your common difference is your slope. Our slope in front is -1. So it's -1. And we'll go ahead and say for integers n greater than 1. But we have to work a little bit to get the first term. So in this equation, this is the 0 term. We need the first term. Using our pattern, every single time it's supposed to be subtracted by 1. So ours is going to be the number 6. Okay. You can also use the explicit formula on your note card to solve for that. It says that the first term you can take d and then n minus 1 here. We know the 0 term, so we can say that the 0 term is 7. We're trying to solve for the first term. We don't know it. We do know the common difference is negative 1, and we know n in this case is 0. So then solving, we get 7 equals first term. This says minus 0. If we well, let's not distribute. Let's just call this negative 1. Negative 1 times negative 1 is positive 1, which means we subtract 1 to solve, and we get 6. Okay, instinctively, if you can make the pattern go forward, you can make the pattern go backwards and kind of work through what your first term would be. Okay, so that is recursive. Okay, so last one here, we're supposed to write both given this sequence. I want you to pause the video and decide if this is arithmetic or geometric based on the pattern. If it's arithmetic, give me the d value or the common difference. If it's geometric, give me what it's multiplying by each time. Okay, not division, you want to think multiplication. Pause the video and try this for me. Alright, it told us geometric, but I'm telling you right now, I will not give you that on the test. I'm just going to give you and you have to recognize. Okay, so here the increase would be 1/3. It's not an increase of 1/3, so it cannot be arithmetic. So to test geometric, we look for multiplication. So we're saying 2/3 times something is 1. Well, that has to be 3/2 because we need to use the inverse, the multiplication inverse or the reciprocal in this case. But the easiest one to see here is 1 times something gets you to 3/2. It has to be that 3/2. So our rate this time is the 3/2, and we're going to plug that in for our explicit. Okay, so again, I'm going to just copy the formula. This is on your note card, and we will just fill it in. So first up, that's part of our equation that stays. First term was given to us as 2/3. The rate we just solved for is 3/2, and then we go n minus 1 for our power. Part B is the recursive, and I'm going to use this whole space. First write the first term, and that's that 2/3 again. And then the nth term is the rate times the previous term. So our rate was 3/2. And I like to, instead of saying times, just throw this thing in parentheses. Okay, you can put it there as well with the times if you like it, but it's the previous term, n minus 1. Please do make sure that all of your subscript notations are lower and smaller than your original. And then where n is greater than 1, and an integer. I do want to point out one more thing that I missed earlier that you may have seen. Sometimes they will say greater than or equal to 2 instead of 1. I'll always have you use what you see on the note card, but greater than or equal to 2 is equivalent, so your choice. Alright, last thing I'm going to do before I get off here is tell you about something to expect for the homework. On the homework you have some word problems, and I just want to give you a reminder of what words could mean arithmetic and what words could mean to use your geometric formula. In general, you're always going to write the formula that is explicit for either of them. Okay, that's the one that's more user-friendly, that'll let you answer the question in the end. Okay, we know that arithmetic is a line and geometric is exponential, but in word problems they're not going to say it's a line. Okay, arithmetic is something that will be an increase or decrease of the same number each time, whereas exponential is going to be an increase or decrease of the same percent each time. Okay, the whole idea of geometric is it has a rate, and the biggest example of that in real life is a percent. So if you see that, automatically geometric. Okay, but again, use your y equals mx plus b to think this through, and for us that looks like a n equals on your note card, first term plus d n minus 1, or of course, literally this a n equals your slope, which is your d, your n, and then this b would be the 0 term. Doesn't exist, but it is equivalent. Okay, I do want the simplified version in your final answer. This is what's on your note card. You'll have to just distribute. Exponential looks like y equals ab to the x on your note card. It uses g for geometric, first term, rate, and the biggest difference is the power. It's really important that you're asking yourself if the initial value is supposed to be at time 0, or if your initial value is supposed to be at time 1. Some of these word problems, you will use the regular power of x because it wants you to have 0 be the beginning. Some of the word problems, 1 is going to be the beginning, and you really want to use this formula that you have on your note card. Okay, so do be careful with geometric, and of course if you have any questions, please come see me.